Okay, this question is an energy related question. So what happens is we have a child uh, that slides down a slide. The child was initially at 2.3 meters away from the bottom. Okay, and so it started at rest, so it has an initial velocity of 0 and drops down to the bottom, so we need to find the final velocity. We also know that throughout the sliding, the child actually loses some energy to friction. Let me just put just the value 361 joules. Okay. Also, let's set the beginning point where the child started off as origin. So again, always remember energy is conserved. So total energy before, same as total energy after. But in this case, there's a non-conservation of mechanical energy. Mechanical energy is with reference to potential and kinetic energy. Okay, let's just look at total energy before and after. So in any state, so total energy in state 1 is equals to total energy in state 2. Okay, so we have potential energy in the beginning. We also have kinetic energy in the beginning. And then we also have potential energy at final plus kinetic energy at the final. And remember I said total energy in any state. So there's some energy that has been lost to friction. So I would actually put energy lost to friction on this part. So total energy in the beginning when the child has potential energy, and that potential energy actually has converted to some kinetic energy and some losses due to friction. Okay, let's write out the whole equation. So mg0, because we have set the origin at the top, plus half m0 square equals to mg minus 2.3 because it's below the origin, plus half mv squared plus 361, which is the energy lost to friction. So if I were to rearrange the formula, I have half mv squared. I bring the 316 over, which gives me negative 361 plus mg times 2.3. Okay. So what happens is I have half mv squared equals to negative 361 plus 19 times 9.81 times 2.3. That gives me 67.7. And if I do v squared, I actually get equals to 2 over m times 67.7, which is equals to 7.126. So therefore v is equal to square root of 7.126, which is equals to 2.67 meters per second. So that's how we get the final velocity when the child reaches the bottom of the slide.